Okay, this question says Aloha Airlines Flight 007 is flying due east. That's important, but finds it necessary to detour around a group of thunder showers. Plane first turns at a bearing in north 58 east, flies for a while, then second turns to intercept the original path, travels for 75 kilometers south 42 east back to the original path. As stated, the plane traveled 75 in the second leg of the journey. How far did it go in the first leg? Okay, so let's be clear. So first up, the Aloha Airlines flight is trying to go due east. So let's make a little axis system here. And you know how this works, right? North, south, east, and west. The plane is trying to fly, is flying due east. So let's draw that. That's the direction the plane is flying. Plane is flying due east. Okay. But finds it necessary to detour around a group of thunder showers. The plane first turns at a bearing of north 58 east. So whenever they give us one of these bearing things, we draw our axis system and we do what it says. What is it saying? Start with north, but then go 58 to the east. So start with north, but then go 58 degrees towards the east. This is 58, right? That's what they're saying. North, but 58 to the east. So this direction. So let's draw that. So the plane turns right here. That a little better at the end there. There we go. And so this angle is 58 degrees here, turned that way. And that's the first turn it makes, right? First turns at north 58 east. So north, but 58 to the east, heads that way. Flies for a while. Then second turns to intercept the original. It's going to go back to the original path and travel 75 kilometers at south 44 east. So again, they're giving me another bearing. Whenever they give you a bearing right there at that spot, make an axis system. So I'm going to do that. I'm going to go right to that spot right here. And I'm going to make another axis system. That's the key. Whenever they give you a bearing, you got to go right there and make an axis system. And what are they saying happens right there? South, start with south, but go 44 to the east. So start with south, but go 44, right? 44 degrees to the east. That's how the plane heads back to the original path. So let's draw that. So it's going like this, back to the original path. And this is 44 degrees. And it does that for 75 kilometers. So this is the second leg of the journey, and it is equal to 75 kilometers. Right? That's what they're saying. See how I've got an accurate map with angles of what they're saying. Right? This is the second leg of the journey. It went south 44 to the east. This right here is 44 to the east. And it did that for 75 kilometers. Then, as stated, the plane traveled 75 kilometers the second leg, getting back to the path, right? It's back on the original path. And it had to get around these thunderstorms. Or like this area, there must have been storms. Had to go up and around to get back to the original path, okay? How far did the plane travel in the first leg of the journey? So they want to know, what is this? Let's call this X. They want to know how far did it go in the first leg of the journey? The second leg was 75 miles. So we got to find this side right here. How long is this side? So we have a triangle. Clearly we have a triangle. We need to find X, this side of the triangle. So what do we do when we need to find a side of a triangle? We'll start by trying to find all the angles. Let's start with the easy ones. How about this one right here? Can we get this angle? Yeah, because that angle right there has got to be 90 minus 58, doesn't it? So that's, what's that? 32 degrees. That's 32 degrees, right? Because these two have to make 90. They're right angle. These are a right angle together. You got to make 90. So that's 32. Okay, great. Well, that's important because that angle is across from that side. You know what I'm trying to do? I'm trying to use law of sines. Whenever I have a triangle and I need to find one of the sides or one of the angles, well, first of all, I should say when we have a triangle that's not a right triangle, that's when we're going to use law of sines or cosines. Are you clear on that? So whenever we have a triangle that's not a right triangle, how do we find the sides and angles? We can't use SOHCAHTOA, right? Sine, opposite, hypotenuse, all that stuff. Why not? Because that's only for right triangles, right? Sine is opposite over hypotenuse. Hypotenuse means the side opposite the right angle. You got to have a right angle. You got to have a right triangle. So to use SOHCAHTOA, you have to have a right triangle. Well, this is not a right triangle. There's no right angle here. Right. That's why we're using law of sines and cosines. That's what we do. If we have a triangle that's a right triangle, and we need to find one of the sides or one of the angles, we just use SOHCAHTOA. But if we have a triangle that's not a right triangle, we need to find one of the sides or one of the angles. We use law of sines or cosines. So we're going to use either law of sines or cosines. Now, we'd like to use law of sines. That's the one that came first and is easier. That's the one where you have, well, when can you use law of sines? Well, you use law of sines when you have side over the sine of an angle pair, right? Opposite, opposites. So in other words, I have this angle and the opposite side. That's what sine is all about. Saying any side, any angle in its opposite side, when you put the side over the sine of the angle, you can put vice versa, you put the sine on the top, doesn't matter which way, they're going to be equal ratios. So do we have that? Well, we have this angle and the opposite side, and we need to find this side, don't we? So we just need to find what? This opposite angle here. So our business at this point, if we can just find this angle here, then I could set up a law of sines equation. I could just go 75 over the sine of 32 is x over the sine of that angle, right? That's what the law of sines says. Equal fractions. Side over the sine of the opposite angle. Side over the sine of the opposite angle. Side over the sine of the opposite angle. So my whole job now is just to get that angle. How can I get that angle? Well, I can see an easy way. If I extend this side here and just say, hey, bring this guy all the way down to there, then we've got a what? Right angle, little right triangle. All right, I just brought this straight down, and this just sits this straight. And so then this angle is 44, this is 90, so I can find the other one. The angle right there, 90 plus 44 is what's that, 134, and then take that away from 180 because every triangle holds 180, what's that, 46 degrees. So this one, this little angle right here, has to be 46 degrees, doesn't it? Now I can look at the whole big triangle and I can say, x over the sine of 46 is equal to 75 over the sine of 32. There we go. X over the sine of 46 is equal to 75 over the sine of 32. Right? Law of sines. Law of sines. Now I can solve that equation for x. Just cross multiply. We'll get x sine 32 is 75 sine 46. Finish solving for x. Divide by the sine of 32. Boom, boom. Hit the buttons on your calculator, and you've got your answer. There we go. That's how we deal with this. So the key issue to remember is whenever first off, pay attention to due east. The plane is trying to fly due east, straight. Due east means straight east, right? And then when they give you these little compass things, these bearing things, you've got to draw an axis system for each of those, axis system for each of those. And then once you get a triangle, if it's not a right triangle, you know you're going to use law of sines or cosines. You'd prefer to use law of sines. You might wonder, well, how do you know when you need to use law of cosines? When I can't get a ratio. If I cannot get a side and the opposite angle, then, which sometimes you can't. In some triangles, you cannot get the side. They give you maybe this side, but they don't give you this angle. And they give you this side is 78 or whatever, and they don't give you this angle. They give you the angle in between is maybe 36 degrees. That's when you got to use law of cosines, right? Because then I'd have a side, but not the opposite angle, side, but not the opposite angle, an angle, but not the opposite side. Then I would have to use law of cosines, which is a little bit harder. I prefer to use law of sines when I can. When can I? Whenever I had have opposite side and angle. So side, opposite angle, side, opposite angle. Set up the ratio, solve it, law of sines. And there we go.